Hi, this is section 8.3 on geometric sequences. So the definition of a geometric sequence is when you have a common ratio. A common ratio, R, is a number that you multiply to get the next term. So for example, let's say you had 2, 6, 18, etc. This looks like a geometric sequence with a common ratio of 3 because the way you get the next term is you multiply by 3 and 3 and so on and so on. So the next term would be 18 times 3, which I believe is 54. Yes. So on and so on. So that's what the geometric sequence is. And the way you get the common ratio is you divide the second term by the first term, or you divide any term by the previous one. All right, and so that to find the nth term of a geometric sequence, you use this formula, or you can use this formula. So it's analogous to the arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d. But this applies for arithmetic, and this would apply for geometric. Okay, so here's a sequence. It says, find the nth term, the fifth term, and the eighth term. So let's start by finding the common ratio. The common ratio, if you recall, is given by any term divided by the previous one. So I'm using the second divided by the first, which is 1/2. You can verify that. If you multiply this by 1/2, you get 4. If you multiply 4 by 1/2, you get 2. If you multiply 2 by 1/2, you get 1, etc. So now we can use our formula for the nth term to find the nth term. So the first term of the sequence is 8. The common ratio is 1/2 n minus 1. And so that is a formula for the nth term. All right, now to find the fifth term, we simply just plug in 5 in for n. So that's going to be 1/2 to the fourth power, which is 1/16. And 8 times 1/16 is 1/2. Which we kind of already knew, because if you multiply this term by the common ratio, you do get 1/2, and that is the fifth term. So we kind of verified it using the formula. Now let's find the eighth term. So now we're going to substitute 8 in for n. So you're going to have 1/2 to the seventh power. So 2 to the seventh is 128. So you're going to get 8 over 128. We can simplify by 4, I believe. And actually, you can simplify by 8. And we get 1/16. All right, so that is it. Let's move on to the next problem. So this one is also geometric. They tell us it's geometric, so we don't really need to verify it, although we can. But let's find the common ratio first. Second term divided by the first term is -3 over 2. All right, for the nth term, we use the first term times the ratio to the n minus 1, which is 4 times -3 over 2 to the n minus 1 power, and that is the nth term. Now we can find the fifth term by substituting 5 in for n. The first term is 4, and we got -3 over 2 to the 5 minus 1, which is 4. Because 4 is an even number, that's going to make this term positive. So 3 to the fourth is 81. So we have 4 times 81 over 2 to the fourth, which is 16. And then 4 simplifies with 16 4 times. So we end up with 81 over 4 for the fifth term. Let's do the eighth term. So we have 4 times -3 over 2 to the 8 minus 1. So that's 7. 7 is an odd number, so the term is going to be negative. So 3 to the 7th power is 2187. So we have 4 times 2187. Well, actually, it's going to be negative overall, so I'm just going to write -4 times 2187 over 2 to the 7th power is 128. And we can simplify the 4 and the 128 4 goes into 128 32 times. So our final answer will be negative 2187 over 32. You want to leave your answer in fraction form. Actually, because of the problem has decimals, you could write that as a decimal if you prefer. So either one would be correct. All right, now they're asking us to find a specified term of the geometric sequence. So they're telling us it's geometric, so we're allowed to use the formulas that has the two given terms. So unfortunately, these terms are not back to back. This is the second term, this is the fifth term, so we're unable to find the common ratio by dividing. So what we can do though is we can use this formula. I'm going to copy and paste and bring it on over. All right, so let's ignore this for now. Let's just use these two terms in order to find out what R is. So this is our K, A sub K. This is our N, A sub N. So if you use the formula, you're going to get negative 81 is equal to 3 times R to the N minus K, 5 minus 2. So A sub N is equal to A sub R times R to the N minus K. Okay, so now we simplify this. You get negative 81 equals 3 times R to the third. Divide both sides by 3. You get R cubed is going to equal to negative 27. 81 divided by 3 is 27, yes. And now you take the cube root of both sides, and you end up with R equal to negative 3. So now we know the common ratio. So now we can find the n term by using A sub n. Oh, well, we still need the first term. So let's see. Actually, we don't. We can reapply the same formula. You can reapply the same formula. So let's use this as our K, A sub K. So we have A sub 9. That's what we're looking for. So n is 9 is equal to A sub K, which is, we're using this, 3 times the common ratio, R, to the n minus K. N is 9, K is 2 this time. That's our K. So now we have 3 times negative 3 to the 7th. So that's going to be an odd number. So 3 to the, it's basically 3 to the 8th power. But the answer is going to be negative. So our final answer should be negative 6561. All right, let's move on. So now they give us the formula for partial sums for geometric sequences. All right, so it looks a little bit more complicated than the arithmetic one. All right, so let's try to find what the sum of the first 9 terms is. All right, I believe we have everything we need. We have the first term, we have the common ratio, and we have n, so we have everything we need. S sub n is going to equal to A sub 1, which is 3/16, times 1 minus R to the n power over 1 minus R. Okay, so let's do the numerator first. 2 to the 9th, what's 1 minus 2 to the 9th power? That is negative 511. Over negative 1. Well, double negatives, that becomes positive. And so I'm just going to cross out those negatives out. And let's see, so the only thing we can do is 3 times 511 divided by 16. And that will be our final answer. So 3 times 511 is 1533 over 16. That is our final answer. The next problem, so notice we do not have the first term, which we need in order to apply the the formula for the partial sums. So we need to use this formula first. In order to figure out what a sub 1 is. So this will be our a sub 4, which is 4/13. A sub 1 is unknown. R is 1/4, and n is 6, so 6 take away 1. So now we can solve for a sub 1. So that's going to be 1/4 to the 5th power, which is 1/10^24. So that's going to be 4/13 equals 1/10^24 a sub 1. Multiply both sides by 10^24 to solve for a sub 1. And you end up with a sub 1 is going to equal to 4096/13. Okay, so now that you have a sub 1, now you can find the sum of the partial sum of the first 6 terms using the formula. So let's do that now. So we have s sub 6. So now we're using this formula is equal to a sub 1, which we just figured out is 496/13. Okay, times 1 minus r to the nth power, which is 6/1 minus r. All right, so let's do the numerator first. So 4 to the 6th power is 4096. Okay, so this, I'm going to create some space here by erasing this, just to have a little bit more space to work with. So now this is going to be 4096/13 times, I'm going to call 1 4096/4096 minus 1/4096 and 4/4 minus 1/4. So what I did was I changed the 1 to be 40/90, this fraction, so I can have an LCD. This became that. So because of this denominator, that's why I made the fraction the way I did. Similarly, this 1 became 4/4 so that I can have a common denominator. And now we can simplify this. This is going to be 3/4. So I'm just going to cross it out and call it 3/4. And so I'm going to multiply by the reciprocal, since that's how you divide fractions. So times the reciprocal is 4/3. And now I have some cancellation, cancel. And let's see if we can simplify the 3 and the 4095. And it does go in evenly. So 3 goes into 4095, 1365 times. So if you multiply that by 4 and divide by 13, we should get our final answer. Actually, 13 goes into 1365 105 times. So 105 times 4 will be our final answer, and that is 420. So that was quite a bit of work. Moving right along, let's find the sum of this series. So let's start with substituting 1. You're going to get 1/3 because of the negative exponent. If you plug in 2, you're going to get 1/9. 3 squared is 9. If you plug in 3, you're going to get 1/27, etc. until you get to 7. 3 to the 7th is 2187. All right, so you're supposed to notice that this is a geometric series. So it's a sum of geometric series or geometric sequence. So R, the common ratio, is 1/3, because to get from here to here, you multiply by a third. From here to here, you multiply by a third, etc. So because this is a geometric series, we can apply this formula. So once again, I'll copy and paste it. so we can use it. All right, so we know the first term is, so we want the sum of the first 7 terms because it goes from 1 to 7, so that's 7 terms. The first term is 1/3. The common ratio is 1/3, and we are raising this to the 7th power because that's what n is. All right, so let's do the 3 to the 7th is 2187. So similarly to the previous problem, I'm going to call 1. I'm going to call that 2187 over 2187 minus 1 over 2187 over 3/3 minus 1/3. So I'm calling this that because this turns out to be that, and I want a common denominator. And over here, I'm calling this 3 over 3. Okay, so if you subtract, you're going to get 1/3 times 2186 over 2187. And this is going to be 2/3. And if I multiply by the reciprocal, I'll get 3 over 2. All right, we can cross-cancel some things. 3's cancel out, and 2 goes into 2186 1093 times. So our final answer is going to be 1093 over 2187. All right, now they want us to express this sum in terms of summation notation. So we are going to have a summation, sigma. We're going to start at 1, and we know there are 1, 2, 3, 4, 5, 6 terms, so that's going to tell us that we're going to stop at 6. And because this is a geometric series, I can tell already because you're multiplying by -2, -2, -2, -2. Our common ratio is -2. So we can use our formula in order to find the nth term, a sub 1 times r to the n minus 1. Okay, the first term is 2. The common ratio is -2, n minus 1. And that is it right there. Okay, so that is going to be our final answer. If you want to test it, you can. If you substitute 1, you're going to get 0. -2 to the 0 is 1. 1 times 2 is 2. If you plug in 2, you get 1. -2 to the 1 is -2. -2 times 2 is -4. So you will see that it will give you the exact numbers that you see up there. Let's try this problem. So we're probably going to just focus on the denominators. And sure enough, if you look at the common ratio, it appears to be -3 times 3 times 3 times 3. 36 times 3 is 108. And because the signs are alternating, that means it's going to be -3 for the common ratio. Actually, sorry, -1/3. Because if you multiply this by -1/3, you'll get that. If you multiply this by -1/3, you get that. Etc., etc. All right, and so our summation looks like this. K equals 1. There's 1, 2, 3, 4 terms. A sub n is going to equal to a sub 1 times r n minus 1. A sub 1 is 1/4. Common ratio is -1/3 to the n minus 1 power. So that is our answer. Okay, moving on. So now we have a theorem on the sum of an infinite geometric series. So infinite just means it continues for indefinitely. Okay, so as you can see, this one continues indefinitely because of the ... And let's check to see if it's a geometric series, even though it tells us it is. Let's find the common ratio. Well, to get from here to here, you multiply by -1/2. To get from here to here, you multiply by -1/2. From here to here, -1/2. So is negative 1/2. There is one thing we need to check. If the absolute value of the common ratio is less than 1, then the infinite series has a sum. If it's greater than or equal to 1, then the series goes to infinity. In this case, the absolute value of negative 1/2 is less than 1, so therefore we can apply that formula. That means the limit is finite, or the sum is finite. So let's apply the formula. S is equal to the first term over 1 minus the common ratio. First term divided by 1 minus r, there it is. Double negatives becomes positive, and also you can change the 1 to be 2 over 2. So I changed the 1 to be 2 over 2, that's the same thing. Double negatives becomes positive, and so now you have 1 over 3/2. That means reciprocal, which is 2/3. And that will do it. Let's check the next one. It appears to me that the common ratio is 3/2, 3/2, 3/2, and sure enough it is. Okay, because the common ratio is actually greater than 1, that means the sum is infinite. That means the sum is just infinity. Or you can say does not exist. Does not exist just means that it continues forever. In other words, the sum is infinity. Okay, so let's look at this problem. It says find the rational number expressed by the repeating decimal. So notice that we're going to change this repeating decimal to be a fraction. So the way you do that is you look at the part that is repeating. It's the 1/7 that keeps repeating. So if we write this out, that's the same thing as 2.4171717, etc. Okay, so this is going to be a geometric series. You'll see we have 2.4 plus the repeating part. The repeating part I'm going to write in parentheses. So that's going to be 0.017 for the first portion for this part. And then you're going to add, to get the next 17, you have to add 3 zeros before you add the 17. And then for the next one, you're going to add 1, 2, 3, 4, 5 zeros before you add the 17. 1, 2, 3, 4, 5, 17, etc. So as you can see, the part that's in parentheses is a geometric series. And it has a common ratio, and the common ratio is going to be this number divided by that number. So the common ratio is the second term divided by the first term, which is, let's figure that out. It's going to be 0.01. If you prefer fractions, that's 1 over 100. All right, so 1 divided by 100 is 0.01. So it depends whether you prefer to use decimals or fractions. Either one is fine. And because this is an infinite series, we can use the formula, a sub 1 over 1 minus r. A sub 1 is the first term. Notice that we're ignoring this. We're only focused on the series in the parentheses because that's the repeating part. So this is your first term. And 1 minus r. I'm just going to go with the decimal in this case because this is a decimal, so I'll just keep this in decimal form. So if you work this out on your calculator, just make sure you put parentheses here. If you're working this out on your calculator, 0.017 divided by parentheses 1 minus 0.01, close parentheses. Actually, I'm sorry, you need to use, you should use fractions because the point is to get this in fraction form. So let's do fractions here. So this is the same as 17 over 1,000. All right, that's the same as that. And then the denominator is going to be 100. Okay, my pencil is failing to work. Here we go. 100 over 100 minus 1 over 100. So we have 17 over 1,000 times the reciprocal is 100 in the numerator and 99 in the denominator. And we can cancel out 2 zeros with 2 zeros. And so now we end up with 17 over 990. Okay, so that's just the repeating part, but we still have the 2.4 that we need to add to this. So let's add the 2.4. Well, 2.4 is really 24 over 10. That's 2.4. All right, the common denominator is 990. So I'll have to multiply with times 99, top and bottom. So that should do it. 17 plus 24 times 99 is equal to 2393 over 990. So to check your answer, all you have to do is type this into your calculator, and it should give you this repeating decimal. So type in 2393 divided by 990, and you will get this repeating